Hello friends, welcome to Akul Mac Live. The new engine CE20 provides the engine power to the upper stage of the heavy lift LMV3 from ISRO. The vehicle chosen for the Gaganyaan mission to carry Indian astronauts, which are also known as Gaganyatris, into orbit. This innovative starting techniques make the LMV3 rocket crucial cryogenic stage more reliable and efficient than ever before. It drastically simplifies the ignition process, enhancing the overall safety and performance of the human rated launch vehicle, also known as HLMV3. Let us explore this further. Welcome to the forefront of India's space ambition. The Indian Space Research Organization ISRO has done it again. It's an engineering feat that may not grab the headlines like a moon landing or a Mars orbit, but it is a fundamental game changer for the nation's most crucial mission, which is known as Gaganyaan. The workhorse of Indian heavy lift, the LMV3 rocket, just received a critical performance upgrade. It's an internal deep seated technological supercharge, and it is all thanks to the brilliant innovation in the CE20 cryogenic engine. To understand why this is a supercharge, we first have to understand the LV3 or the launch vehicle Mark 3, often called the Bahubali of Indian rockets. This three-stage vehicle is India's most powerful. It's what carried Chandrayaan 3 to the moon, and it's the vehicle chosen to carry our astronauts, our Gaganyatris, into Earth floor orbits. The final crucial stage of this rocket is the C-25 cryogenic upper stage, powered by the CE20 engine. Now, what are cryogenic engines? They are the Ferraris of the rocketry. They use propellant liquefied at incredibly low temperatures, which is liquid hydrogen at minus 253 degrees centigrade, and liquid oxygen as at the minus 183 degrees centigrade. These are fairly low temperatures. This combination is highly efficient, giving a rocket that final powerful push it needs to reach orbit or travel to deep space. But their power comes with a fundamental challenge. Starting them is notoriously complex. Traditionally, to get a cryogenic engine running, you need to spin up the turbopumps, the high-speed devices that forces the super cool fuel and oxidizes into the combustion chamber. The conventional method uses, across much of the world relies on the stored gas system. You bring a tank of highly pressurized inert gas along with the ride. This stored gas hit the turbo pumps to kick-start them. While reliable, the system has three major drawbacks for human-rated vehicles like Gaganyaan. It adds weight. That gas bottle is dead weight that could have been used for other things like other payloads. It limits flexibility, and if you need to stop and restart the engine in space, which is essential for certain advanced maneuvers or future deep space mission, you need enough stored gas for every ignition. It is a point of complexity that must be rigorously managed for a mission carrying human life. For the human-rated LMV3 or HLMV3, ISRO needed something better. They needed a way to start this massive, complex, final stage engine without any stored gas at all. They needed a bootstrap start. The term bootstrap start sound deceptively simple. It comes from the phrase pulling yourself up by your own bootstrap. In rocketry, it means the engine must use its own nascent energy to start itself, a self-ignition sequence. ISRO engineers at the propulsion complex in Mahendragiri recently pulled off this landmark test, and the result it is demonstrating is just genius. It truly elevates Indian space status. Here how it works. In the conventional gas generator cycle of the CE20, a small amount of propellant is burned in a separate chamber. The gas generated to create hot, high pressure gas, and this gas is what drives the turbo pumps, which in turn feeds the combustion chamber. The challenge is getting that first tiny spark in the gas generator without external help. ISRO solution involved a multi-element igniter system and exploiting the natural pressure within the fuel tanks. So step 1, the spark. A highly reliable multi-element igniter is activated in both the main thrust chamber and the gas generator. Step 2, the tank head pressure, and they use the ambient pressure, the tank head pressure, also known as tank pressure, to push a tiny flow of propellant into the thrust chamber. This is enough for main chamber to ignite first. Step 3 is it's a self-sustained process. Crucially, the gas generator then kicks in utilizing the same tank head pressure. Once this small ignition is established, it rapidly creates enough hot gas to spin the huge turbo pump autonomously. Next is step 4, which is the supercharging mechanism. The turbo pump spin up to full speed, slamming propellant into the combustion chamber, and the engine seamlessly ramps up to its stable, steady operation thrust of up to 22 tons. Think of it like starting a powerful jet engine. The old way was like needing a separate powerful external battery to turn the fan. The new way, the bootstrap start, is like having a tiny, clever internal ignition system that uses the residual energy of the engine to fire up the main turbine by itself. The key phrase here is without relying on any auxiliary stored gas system. This is a significant global achievement, putting ISRO on a very short exclusive list of space agencies mastering this complex technology for gas generated cycle engines. The test was conducted under simulated high altitude vacuum conditions, mimicking the actual environment of space. The engine ramped up smoothly, demonstrating that this self-ignition is not just possible but reliable and repeatable under real mission conditions. This isn't just a lab demonstration. The CE20 engine is the final orbital insertion stage. A failure here means mission failure. By simplifying the start sequence and removing the dedicated auxiliary hardware system, ISRO has massively increased the reliability and inherent safety of LMV3 for human missions. The complexity moves from hardware, which can fail, to software and engineering know-how, which once proven is exponentially more robust. And this is a supercharge. The successful bootstrap test has far-reaching implications, extending well beyond simply proving a new technology. It fundamentally altered the trajectory of the Indian space program. For the Gaganyaan mission, safety is paramount. The elimination of the stored gas system removes an entire subsystem that could potentially fail. It makes the HLMV3 a cleaner, more streamlined, and inherently safer vehicle for our astronauts or Vyomnauts. This successful test is one of the final critical check in the long process of human rating a launch vehicle, providing maximum confidence in the system that will deliver the first Indian crew into the orbit. By removing the weight of the auxiliary startup system and their associated plumbing, the LMV3 becomes lighter. The rocketry, every kilogram saved in upper stage translate to hundreds of kilograms of extra payload delivered into the orbit. ISRO has already been working to increase the LMV3 payload capacity. This breakthrough accelerates that effort, making it more efficient, more commercial satellite launch and future heavy payloads. This is perhaps the biggest strategic advantage. The bootstrap start doesn't just enable a single reliable start, It enables multiple reliable restarts in space, and let's understand why this is critical. The LME3 can now deliver multiple satellites into different orbits using one single launch, dramatically increasing the vehicle's commercial value and mission flexibility. Deep space trajectories, which are like for the future mission to Mars and Venus or beyond, requires highly precise mid-course correction, which often means reigniting the cryogenic engine thousands of kilometers from Earth. The bootstrap start makes it, this complex feature possible, paving the way for India to explore the solar system with greater ambitions and precision. This technology, developed entirely in-house by ISRO's Liquid Propulsion System Center (LPSC), cements India's position as a leader in advanced cryogenic technology. It's a powerful statement of Atmanirbhar Bharat, self-reliant India, in the highly competitive and strategic domain of heavy lift human spaceflight. The CE20 engine is no longer just a powerful component. With the bootstrap straight breakthrough, it has been supercharged into one of the most reliable and flexible cryogenic engine in the world. It's a crucial step that doesn't just pave the way for Gaganyaan but for the entire next generation of Indian space exploration from Chandrayaan to Gaganyaan. ISRO continues to push the boundaries of what is possible. LME3 is ready, the engine is also ready. India's future in space has never looked brighter. So friends, thank you for watching. Thank you for joining live. Don't forget to like and subscribe for more deep dive into incredible achievements of Indian space and technology. Just in case, if you want to leave a comment or a question, leave them in the comment section below. And I will catch you again in the next one.